lesson 4 on rotations. Brett is spinning the prize wheel shown over here. A spinner can be clockwise or counterclockwise. Defining these two words, okay, we have clockwise, and clockwise is to the right. Let me try and make sure that this is, there we go. Clockwise is to the right. Counterclockwise is to the left. Okay. If the section labeled 8 on the left part of the wheel spins 90 degrees clockwise, where will it land? It will land on spot 3 on the wheel. If one of the sections labeled 4 makes 3 complete turns counterclockwise, how many degrees will it have traveled? It will have traveled 1,080 degrees. Okay. Now, I know you'll be able to see this on your paper, even though I've moved this up. Okay. It says, are there any points on the wheel that stay fixed or do not move when the wheel spins? If so, what are the points? The answer is yes. And that point is the center of the wheel. Does the center of the wheel change if the wheel is spun counterclockwise as opposed to clockwise? The answer to that is no. Does the distance from the center to the edge change as it spins? The answer is no. And to explain this, rotating a shape does not change the side length or angles. Okay. Next, a rotation. A rotation is a transformation in which a figure is turned about a fixed point. A rotation does not change the angle measurement. Side length or shape. We have 4 degrees of rotation. Those rotations are, let me move this up just a little bit. I will get used to this, guys, one way or another. All right, those are 90 degrees, or 1/4 of a turn, 180 degrees, half a turn, 270 degrees, 3/4 of a turn, or 360 degrees, 1 full turn. And for this, there is no change. Okay. So now, knowing this, okay, knowing this, we're going to try one. We're going to try one. Okay. We're going to need our rulers for this. We need our rulers for this. Triangle PQR is located in quadrant 1 on the graph below and has the following coordinates. On my graph, I have to graph it. So we are going to graph P21, which is right here. Q5, so 1, 2, 3, 4, 5, and 2, 1, 2. And 4, 5, so 4, 1, 2, 3, 4, 5. So we have R, Q, and P. And let's draw that. As always, you are to use a ruler, ladies and gentlemen. Getting stuck on my paper there. Here's my triangle. We're going to find and graph the coordinates of a rotation 180 degrees clockwise. Notice that counterclockwise is the same about the origin. We're going to list the new coordinates. Okay. Now, for 1 full turn is 360 degrees. Okay. There are 4 quadrants. So therefore, each quadrant is worth 90 degrees. Okay. So rotating 180 degrees is 2 quadrants. Okay. In other words, for rotating it clockwise, our x and y here would make it negative x, negative y. So our new coordinates for this, and let me move this up, our new coordinates for this, okay, would be P is 2, 1, Q is 5, 2, and R is 4, 5. Our new points then would be P prime would be -2, -1. Q prime would be -5, -2. And R prime would be -4, -5. Because what we're doing is we are turning it one rotation and then another rotation. That's what we're going to do. So to plot these points, I have -2, -1 here. This is P prime. We have Q at -5, 2, 3, 4, 5, and -2. That's Q prime. And R at -4, -5. So if you notice, we rotated it 1/2 of a turn. So next, we have a rotations practice. So what we're going to do is we have a triangle x, y, z, and we have its coordinates, and we are going to graph the XYZ after rotation of 180 degrees counterclockwise. In other words, again, whether we do it clockwise or counterclockwise, it is the same thing. So first of all, let's do X, Y, and Z. So we have 3 and -1. We have 5 and -4. And we have 1 and -5. So our new coordinates, because it's 180 degrees, x prime would be -3, 1. Y prime is going to be -5, 4. And z prime will be -1, 5. So let's graph these. Okay, so I have -3, 1. I have -5, 4. And then I have -1, 5. So I have x prime, y prime, and z prime. So again, we rotated it from here to here. Okay. So now what I'd like you to do is discuss with your partner and compare and contrast. Okay. You compare and contrast the properties preserved for rotation versus the properties preserved for a translation. Okay. So what do you think are preserved? I'll give you a minute. Okay. Well, angle measurement side length and shape. Now, I want you to make a prediction. What do you think will happen to the x and y coordinate when the shape is rotated only 90 degrees? What do you think will happen? Again, if we go back here, now you know what happens with 180 degrees, okay? The x and y values are the opposite as far as the negative and positives. What do you think would happen with the 90 degrees? So if they go from here to here, what do you think would happen? In other words, again, it's rotating though. So what do you think would happen? Okay, so let's make a prediction. We are going to find out. And here we go. Okay. All right, here we go. We're going to find and graph the coordinates of the following rotations. Okay, so here we go. We are going to plot the triangle with the points 2, 1, 5, 2, and 4, 5. So let's do that first. Okay, let's do that first here. Okay, so we are plotting 2, 1. And I'm going to do them in different colors so we can see. 5, 2. And 4, 5. So here's our first one. Our next one, we are going to rotate 90 degrees. Okay. So if I rotate it 90 degrees, okay, and we plot our new points, okay, and we rotate it clockwise, in other words, clockwise here, what happens is our new point for P is going to be here. And what we can do is we can use our transparency to do this. Okay. And let me get that. So now, by rotating that, we're going to take our transparency, and here's my point for P. Okay, we're going to rotate that 90 degrees. Okay, here's our 90 degrees. We're going to rotate that 90 degrees, right like that. And we are going to find our new points now. So our new points are right here and right here. So our new points then are 2 and -1 and -2. So 1P is going to be 1 and -2. So I'm going to come up here and list my new points. So P prime is going to be 1, -2. Q prime is going to be, and let's come back down here. Let's just mark these points real quick. Okay. There we go. So let me put these in. I've got this right here. And I've got, let me move this point right here. Let me move this away. So we have P prime here. And then we move this for Q here, prime, and R prime. So we have 2 and 1, 2, 3, 4, 5. So we have 2 and -5 for Q prime. And then for R prime, we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and -4. Okay, so let's put that together. I'm just drawing it again so that you can see it. There we go. My ruler again. Okay. So look at the difference. Look at what happened between these points and these. Okay. What do you see? Okay. Our rule. We switch. Oh, let me erase that. Spell it right. The X and Y coordinate and make the second one opposite. So in other words, for 90 degrees, we're going to make that equal to y, comma, negative x. For 270 degrees, okay, 270 degrees, I'm going to go 90, 180, 270. And here are my points. So I'm going to put them in. I've got here, here. I have up here. And then I have right here. Okay. So again, I get P prime, double prime actually. And then I have Q double prime and R double prime. So let's draw that. Okay. So now our points for that are going to be P double prime is going to be -1, 2. Q double prime is going to be -2, 5. And R double prime is going to be -5, 4. So our rule for this is to switch the X and Y coordinate and make the first one opposite. So now for the rule for that one, will be -y, x. Okay. So that's our lesson for today.